All right, time to jump into what gates are. And as I mentioned at the beginning of this module, I've been looking forward to creating these lessons for a long time. It's one of the first lessons I remember teaching way back when, and I just think it's really cool stuff. It's some of the first stuff I've learned when it came to electronics, and I love geeking out over this stuff. So let's take a look at gates and what gates are. Gates are made up of different amounts of transistors. And as we mentioned before, if we press a 1 on here, that means that we're applying power to it. But let's just say we're pressing the button, or have an input of 1 here. Then what's going to happen is it's going to make contact here and power will flow through here. However, we release that, so essentially we're putting a 0 in there, and now power can't make it through this conductor because there's a gap now, and so it's not going to get onto the other side. Now the mechanics of a transistor works differently than that, but we're just using this button as a representative of that transistor. So let's first of all make an OR gate. As you can see here, I have 2 transistors. And what an OR gate says is that if one of the transistors or the other transistor or both transistors are turned on, the output will be 1. Otherwise, if there's no input on either of those, then the output is going to be 0. So I just gave away the answer to what we're going to be creating here, but let's go through this process here. There is power put to the circuit right here, so we've got a positive charge right here. And let's say we have a 0 and a 0 inputted into here, then what happens is no electricity can pass from this side or this side, and so we don't have any output right here. And so therefore we have an output of 0. Now what you can do is you can try to fill in the rest of the, play around with this and start putting 1s on each side and see if you can come up with what it is this table is going to look like with the outputs. So what you can do is you can go ahead and pause the video, go through this exercise and see what you come up with. And then you can play the video and we'll walk through it together. Okay, let's see what this looks like. So what we're going to do for the next one, the next input is 1 and 0. So let's do a 1 and 0 for this and see what this looks like. So what happens is we push this button down and we get electricity through here and out this side. Well, shoot, we don't even need to take a look at the side, but it would be a 0 on that side. But we're getting power through this output. So now we've got a 1 in this column, this output right here. All right, now let's take a look if we have a 0, 1. These are the 2 inputs, 0, 1. And so in this scenario right here, let me remove some of these marks so that way it's not so cluttered here. Okay, so in this case right here, now we have 0, so nothing is flowing through this side, so we're not getting any power from that side. But this side, now power can go through because we're depressing this button right here. So because of that, now we get a 1, so we can put a 1 right there. And now let's go ahead and press a 1 right here. Now we get power from this side. So whether it's this side that's depressed or this side that's depressed or both, it's going to operate as 1. So there's the answer right there. Another one that we have is the AND gate. So let's go ahead and go through the same process here. Rather than me telling you what the answer is, go ahead and try to figure out this table. Input 1 and input 2 are right here. And what is going to be the output given these set of inputs into it? Go ahead and pause the video, see if you can figure it out, then play, and then we'll walk through it together. All right, so let's see what happens here. So if we have a 0 and a 0, and electricity gets applied here, can't go even through this first transistor here, so it never makes it to the end here. So that's going to be 0. So next up, we have a 1, 0. So we press this right here, electricity gets through there, but can't get to this point right here. By the way, electricity works a little differently than that, so forgive my terminology there. But essentially, so it gets stopped right here at this switch right here, or this transistor right here. So once again, there's a 0 output, so we've got a 0 output. Now let's switch these around. This is 0 and 1. And so electricity can't make it past this first transistor here, so it can't ever get to the end, so that's going to be a 0. Now let's have both 1s. At this point in time, electricity can pass through here and through here. Now we finally have a 1. So this needs to be a 1 and this needs to be a 1, hence the name AND gate. So they both have to be present in order for us to get a 1 right there. Then we have a NOT gate. A NOT gate just says if we press this button, so there's an input of 1, then it's going to break the connection. So notice I flipped this around so it looks a little different, and it looks like that when we press the button or give an input of 1, then it breaks the contact. Normally there would be contact if there's a 0 up here, but then it breaks the contact if we put a 1 there. So as you can guess, that means if we don't press it, then we have an output of 1, and if we do press it, then it breaks the contact, doesn't flow through, and we have an output of 0. So the NOT gate just inverses whatever the input is going to be. So here is the summary of what each one of those gates are. So this is the AND gate right here. This is the OR gate, and this is the NOT gate. From a symbols perspective, this looks like this one right here. And then the OR looks a little different. The actual symbol for it, this looks a little more pointed. I couldn't quite find something that worked quite right for that, but essentially it's close there. And then the NOT gate, that's what the symbol looks like for the NOT gate. And here's the output cable, tables for each one of those. So there are other gates out there, like the XOR gate. So just realize that this isn't a complete view of all of the gates that you could put together. But do realize now what we've created is a building block to create some sort of circuit that performs some sort of function. The function that we're going to create next is a half adder. What it's going to do is it's going to add a column together. So let's take a look at that in the next video.